Jai Shri Gurudev. Good morning to everyone, students. The next concept is wave nature of electromagnetic radiations. Before going to study wave nature of electromagnetic radiations, let me have to know something about electromagnetic radiations. So here the electromagnetic radiations consists of many radiations like X-rays, gamma rays, UV rays, cosmic rays and visible rays, higher rays, etc. All these radiations having different frequency, wavelength, amplitude and wave number, etc. Okay, those we are studied in later. Now, the scientist Maxwell observed that the X-rays, gamma rays, heat and some more radiations emits energy continuously in the form of radiations or wave, so that the emitted energy is called radiant, and these electromagnetic radiations is associated both electric field and magnetic field. So now observe here, the word itself says electromagnetic, the word itself says it associated both electric and magnetic field. Okay, hence these radiations we call electromagnetic radiations. Now for these radiations has some properties, those we are studied here. The properties of electromagnetic radiations are the first one, the electromagnetic radiations is associated both electric field and magnetic field. The electromagnetic radiations associated both electric field and magnetic field. Okay, so now observe, let's take an axis, one is x and one is y. So this is x-axis and this is y-axis. So I told you the electromagnetic radiation is associated with both electric field and magnetic field. Now this is, let us assume, electric field. Like that, the electric field is traveling, and the magnetic field will travel perpendicular to this electric field. Let's take this is electric field. And the magnetic field will perpendicular to the electric field. That is, observe, this is magnetic field. Like this is the magnetic field is traveling. Like assume this is magnetic field. So here let us assume this is the electric field. This duster is an electric field which is passing to the x-axis, and the magnetic field will be perpendicular to this one, perpendicular like that. This is towards you and this is in the direction of x. Here there is an angle, right? This angle will be 90 degree. Like that, these two are propagating. But these two are traveling in the same direction, right? Same direction, that is in x direction only, and emit energy continuously. That is here we are saying. That is the second property. The electric field and magnetic field, both are simply I am writing electric field and magnetic field. These two are perpendicular to each other. Okay, this is the second one. Then the third one, the electric field and magnetic field, or the electromagnetic radiations emit energy continuously in the form of radiations or wave. These electromagnetic radiations, that is EM radiations, electromagnetic radiations emit energy continuously in the form of radiations or waves. Okay, it emits either in the form of radiations or in the form of waves. Then the fourth one, the electromagnetic radiations is traveled with the speed of light. These electromagnetic radiations travel with the speed of light radiations, that is 3 into 10 power 8 meter per second. ಓಕೆ, ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ ನ ಸ್ಪೀಡ್ ಅನ್ನೋದು ಲೈಟ್ ರೇಡಿಯೇಷನ್ ನ ಸ್ಪೀಡ್ ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. ದೆನ್ ದಿ ಫಿಫ್ತ್ ಒನ್ the energy of electromagnetic radiations is directly proportional to the frequency. Energy of electromagnetic radiations, that is P, is directly proportional to the frequency nu. The electromagnetic radiations energy is inversely proportional to the wavelength. This is inversely proportional to the wavelength. ಯಾವ ತರ ಅಂತ ಹೇಳ್ಬೋದು, either you say directly proportional to frequency or inversely proportional to the wavelength. Okay, this is the properties of electromagnetic radiation. And there is sixth one. These electromagnetic radiations, to travel there is no required to any medium, means no required any medium to travel these electromagnetic radiations. Okay, this is the some properties of electromagnetic radiations. Now after knowing these properties, we have to know some characteristic properties of these electromagnetic radiations. ಈ electromagnetic radiations na characteristic properties ಏನಿದೆ ಅಂತ ನಾವು ತಿಳ್ಕೋಬೇಕು. So here characteristic properties is nothing but either speed or wavelength or wave number or amplitude of these radiations that we learn one by one now. So that is the main characteristic properties of electromagnetic radiation, that is characteristics of electromagnetic radiation. So observe here, I am taking only one radiation, either take electric field or magnetic field. I am taking only one field, either take electric field or magnetic field. You know, like assume this is electric field or magnetic field, that is your wish. So now here there is a peak, it's showing upside, and also there is a peak which is showing downside. The upside peak is called as crest, and the downside peak is called as trough. The upside peak is called as crest and the downside peak is called as trough. So here there is a two crests, there is so many crests in the wave. ಈ ತರ ವೇವ್ ಅಲ್ಲಿ ತುಂಬಾ ಕ್ರಸ್ಟ್ ಇರುತ್ತೆ, ತುಂಬಾ ಟ್ರಫ್ಸ್ ಇರುತ್ತೆ. So here the successive distance between two crests, it means the here to here, this is the successive distance. Illinda iliyonda distance, that is called as lambda wavelength. Similarly, the successive distance between two troughs, ಇಲ್ಲಿ ಮತ್ತೆ ಇನ್ನೊಂದು ಟ್ರಫ್ ಈ ತರ ಹೋಗಿರುತ್ತಲ್ವಾ, so here the successive distance between two troughs is also called as wavelength lambda. Okay, now the height of the crest, this one, the height of the crest or depth of the trough, height of the crest or depth of the trough is called as amplitude. Height of the crest or depth of the trough is called what? Amplitude. And similarly, the number of waves which is propagated in a given one hole per second or given a hole per second, that is called as frequency. Okay, and the distance traveled per second is called wavelength, and the reverse of wavelength is called as wave number. Those characteristics we have studied one by one. Now take first one, wavelength. Important. So wavelength, it is indicated by the term lambda. This is lambda. This is pronounced as lambda, indicated by wavelength. So wavelength is defined as the successive distance between two crests or two troughs. Okay, that is, it is defined as the distance between two successive crust or troughs is called wavelength. Okay, that is the wavelength. Wavelength is defined as the distance between two successive troughs and it is indicated by lambda. The SI unit is meters or nanometer. The SI unit is nanometers or 10 power minus 9 meters. That is 10 power minus 9 meters. Nano means 10 power minus 9, that is meters. Okay, this is the wavelength. Then second one, take frequency. This frequency is indicated by symbol nu. This is nu. It is pronounced as nu. That is nu. So frequency is defined as number of waves propagated through a given pole per second. Given pole per second is called as frequency. Number of waves passes through a given point per second is called frequency. Frequency that is indicated by the symbol nu. So here the SI unit is hertz. That is Hz. It is pronounced as hertz. This is the SI unit for frequency. So remember, frequency is nothing but number of wave passes through a given point per second is called as frequency, and the SI unit is hertz, indicated by term nu. Then next terminology is velocity. Third one, velocity. Velocity, it is indicated by V or C. V ಅಂತ ಹೇಳ್ತೀವಿ ಅಥವಾ C ಅಂತ ಹೇಳ್ತೀವಿ. This V is indicated in medium, C is indicated in space. Space ಅಲ್ಲಾದ್ರೆ C ಅಂತ ಹೇಳ್ತೀವಿ, ಮೀಡಿಯಂ ಅಂದ್ರೆ V ಅಂತ ಹೇಳ್ತೀವಿ. ಮೀಡಿಯಂ ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ವಾಟರ್ ತಗೊಳ್ಳಿ, ಒಂದು ಬೀಕರ್ ತಗೊಂಡು ವಾಟರ್ ತಗೊಳ್ಳಿ ಅಥವಾ ಎನಿ ಸೊಲ್ಯೂಷನ್ ತಗೊಳ್ಳಿ, ಅದನ್ನ ಮೀಡಿಯಂ ಅಂತ ಕರಿತೀವಿ. C ಅಂದ್ರೆ ಸ್ಪೇಸ್ ಅಲ್ಲಿ, ಅಂದ್ರೆ ಏರ್ ಅಲ್ಲಿ, ಗಾಳಿಯಲ್ಲಿ ನೋಡಿದಾಗ C ಅಂತ ಹೇಳ್ತೀವಿ. This is the symbol used to indicate for velocity. Either take V or C. This is in medium and this is in space. So velocity is defined as the distance traveled or covered by a wave per second is called as velocity. That is the distance traveled or covered by a wave per second is called what? Is called velocity. Is called velocity, and the SI unit is velocity is meter per second. Meter per second. This is the velocity. So observe, distance means meter, time is second. Here we are saying per means 10s4 minus 1. That is meter per second is the SI unit for velocity. So here C is equal to 3 into 10 power 8 meter per second. This is the speed of light. Speed of light. Speed of light is nothing but what? Velocity of light. That is C is equal to 10 power minus 8 meter per second. Then next one, wave number. That is wave number. Wave number, it is indicated, this is represented as nu bar. Wave number, it is represented as nu bar, that is reciprocal of wavelength. So wave number is defined as reciprocal of reciprocal of wavelength. Wavelength is called wave number. So the SI unit is, for wave number the SI unit is centimeter or nanometer, or simply we have written meter. For wave number is, it is inverse, that is SI unit is centimeter, that is per centimeter. Per centimeter. This is the SI unit of wave number. Then take amplitude. The next one is amplitude. This amplitude is indicated by the symbol A. This is the symbol A. Amplitude I have already told you. Amplitude is defined as the height of the crust or depth of the trough. It's called amplitude. So it is height of crust or depth of trough is called what? Amplitude. This is the amplitude and it is indicated by the symbol A. Then the SI unit is, so observe, the height is measured in watt. It means it is in terms of length, okay? It means meters. So this is the SI unit of amplitude is meters. This is the SI unit. Now we know some characteristics of electromagnetic radiations. Now we are relating or finding the relation between these characteristics. It means the relation between wavelength and energy, frequency, amplitude, wave number, velocity, etc. That is the relation between energy, wavelength, wave number, frequency, heat. That is, we are going to find. You know, in the beginning only I told you in the characteristics of electromagnetic radiations, the energy of electromagnetic radiations is directly proportional to the frequency or inversely proportional to the wavelength. Therefore, that is shown by Planck. So according to Planck is a scientist. According to Planck, we know that he is directly proportional to the nu, that is frequency. So by remaining proportionality constant, we are putting he is equal to h nu. So very important. This is called Planck's equation for energy. Planck's equation for energy, very important for 1 mark. They will definitely ask, either they ask problem on the basis of this equation. E is equal to h nu. Then nu is nothing but what? Frequency. That can be represented like or written like nu is equal to 1 by lambda or c by lambda. C is the speed of light, that is velocity divided by lambda, that is nu is equal to c by lambda. Therefore substituting in this equation, E is equal to what you get? E is equal to h into c divided by lambda. Okay, and we know that 1 by lambda is equal to what? Nu bar. This is wavelength and this is wave number. You know, in the definition I told you, the wave number is the reciprocal of what? Wavelength. Okay, it means inversely proportional. Reciprocal means inversely proportional. That is 1 by lambda is equal to nu bar. So here there is a 1 by lambda, right? So that this can be written as what? C into 1 by lambda is what? Nu bar. So that this can also be employed as, means it can also be written like what? E is equal to h into c into nu bar. H into c into nu bar. So this is the relation between different terms. In the terms of wavelength or frequency or wave number, these are the relations. Okay, so observe, this is the relation between wavelength and wave number. And this is the relation between energy and frequency. That can be written like that. That is E is equal to h nu. This is the relation between energy and frequency. And this is the relation between energy and velocity, c, velocity, that is speed of light, and also wave number, sorry, not wave number, wavelength, lambda, and this is the relation between frequency and wave number, and frequency and wavelength, and frequency and velocity also. So this is the energy between, that is relation between energy with the speed of light, means velocity, and nu bar, frequency. And here h is called as Planck's constant. H is called as Planck's constant, that is h is called as Planck's constant. I write here h is equal to Planck's constant. Its value is 6.626 into 10 power minus 34 joule second. This is the Planck's constant. Remember the value, it is helpful to solve the problems. This is the Planck's constant value. Here there is a h, right? By removing proportionality constant we are putting h. This h is called Planck's constant. Its value is 6.626 into 10 power minus 34 joules second. So here we enter joules, it means it is a form of energy. Okay, so this is the electromagnetic characteristics, and after knowing that we are going to study spectrum of electromagnetic radiations. This is the electromagnetic spectrum. So listen here. In the beginning only I told you the electromagnetic spectrum consists of many energies or many number of radiations. Here those are gamma rays, alpha rays, UV rays, visible, higher, microwaves, radio waves, and long radio waves. Again there is a, in this long range, after that short radio waves also there. Just I am writing long radio waves. After gamma rays, here there is a cosmic rays also. All these are belongs to the electromagnetic radiations. Here the electromagnetic radiations is defined as, or the electromagnetic spectrum is defined as the arrangement of different electromagnetic radiations in the increasing order of their wavelength or decreasing order of their frequencies is called as electromagnetic radiation. So here observe, either it will be defined increasing order of wavelength or decreasing order of their frequency. So if you go from this side to this side, means left to right, if you are moving, wavelength will be increases. If wavelength increases, frequency definitely decreases. Those two are reciprocal to each other, means opposite to one another. Okay, that is the electromagnetic spectrum is defined as the arrangement of different electromagnetic radiations in the order of increasing their wavelength or decreasing in their frequency is called electromagnetic radiations. The top side represented values, these are called frequency, that is in the decreasing order. Observe from 10 power 24 to 20 to 20 like that, the frequency will be decreases to 10 power 0, it means 1. Okay. Then the downside we are representing the value, that is 10 power minus 16 to 10 power minus 14, 12, 10, minus 8, minus 6, like so on, 10 power 8. So it means the values will be increases right now, so that the wavelength is increasing order. Again here there is a visible rays. So here in these radiations, in these electromagnetic radiations, higher micro radio waves, long radio waves, and short wave radios, and UV, alpha, gamma, and cosmic rays, these all not can't see from naked eyes except these visible rays. So that we are giving the name visible. Visible it means ನೋಡಬಹುದು ಅಂತ, we can see, right? So again these visible rays can be contain these 7 rays, 7 color radiations, that is violet, indigo, blue, green, yellow, orange, and red, that is Vibgayar. These are the radiations which are present in the visible radiations. Okay, here you know these radiations are present in the sunlight also. Sunlight that we can see. You know, in your 10th class we observed or we did an experiment to see these visible radiations. If in sunlight we are focusing the scale on our hand, it will be visible these colors also. And we also see in rainbow. ಓಕೆ, ರೈನ್ಬೋದಲ್ಲಿ ನೋಡಿದ್ವಿ ಅಂದರೆ ಕಾಮನ್ ಬಿಲ್ಲಲ್ಲಿ ನೋಡಿರ್ತೀರಾ, ನಾವೊಂದು ಸ್ಕೇಲ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಬಿಸಿಲಿಗೆ ಇಟ್ಕೊಂಡು ನಮ್ಮ ಕೈ ಮೇಲೆ ಫೋಕಸ್ ಮಾಡಿಕೊಂಡ್ರೆ ಈ 5 ಕಲರ್ಸನ್ನು 7 ಕಲರ್ಸನ್ನು ನಾವು ನೋಡ್ಬೋದು. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ದಿ ಬ್ರೀಫ್ ಡಿಸ್ಕಷನ್ ಅಬೌಟ್ our explanation about electromagnetic spectrum. Now we have to go solve problems on these electromagnetic radiations on the basis of Planck's equation. Now take problems.